Welcome to this lecture on process control, Laplace transform chapter. This is part 18. So in this part and in the next 2 or 3 lectures, we will be discussing some forcing functions. Forcing functions are some functions which are used to describe the input for a process. Any process or any system will have an input variables and output variables. So the disturbances to the process are caused on the input side. So when disturbances are caused, so what is the effect? What is the result of that processes of the disturbances? That is what you're going to see in dynamics of process and later on in same thing in control systems. So to study the effect of disturbances in a process or in a system, we need some mathematical equations to model the input. So we need some mathematical equations to model this input. So those equations we call them as forcing functions. So we'll see more about this when we study the analysis of process or dynamics of process. So essentially these forcing functions are used both in process dynamics as well as in control systems. So let us see some important forcing functions. The first one is step function. Step function. What is a step function? So a function whose value changes from one constant value to another constant value suddenly or quickly or instantaneously is called a step function. That means the value changes from one constant value to another constant value. That's important. It changes from one constant value to another constant value. Changes from one constant value to another constant value. Another important parameter is it changes. How does it change? Changes very suddenly or quickly or instantaneously. So that is known as a step function. So instantaneously from one constant value to another constant value. Changes instantaneously from one constant value to another constant value. So let us see the numerical equations. Numerical values of this function. For example, say f of t function for t less than 0, let's say the value is 0, and at t equal to 0 the value of the function becomes m, where m is a constant. So these are the two values of the function. One is 0 at t less than 0, for t greater than 0 it becomes m. So this is the numerical value of the function. So as this statement is explained by these numerical values. For t less than 0 up to time 0, t is less, we can take t as time. For time up to certain time, let's say 0, the value of the function is 0. And at t equal to 0, suddenly it becomes m, another constant value. M is a constant value. So how does it look if you plot this? So if you draw a sketch of these numerical values, f of t equal to 0 till t equal to 0. I have taken this as 0 axis. For easy understanding, for clear understanding, I shifted the 0 from here to here. That's all. Similarly, on the y-axis, I shifted 0 from horizontal to slightly above. So this is 0 on the y-axis. This is 0 on the x-axis. X-axis is time. Y-axis is f function. So up to t equal to 0, the function value of the function is 0. Then at t equal to 0, at this point, it suddenly changes from 0 to m. So it changes from 0 to m suddenly or instantaneously or quickly. So it looks like suddenly changes from here, changes from 0 constant value to another constant value at t equal to 0. Suddenly or quickly or instantaneously. Instantaneously is the perfect word. Changes from one constant value to another constant value m here. Here the one constant value prior to change is 0 and after change is m. So it looks like a step, so that is why it's known as a step function. So these are the numerical values. So as I said, we need equations, mathematical equations to describe this change of values, to describe this function. So that mathematical value, mathematical expression, what will be the equation, mathematical equation for this function? So out of these two values, we will be interested in the period t greater than 0. That is what happens after t greater than 0, after t0. So we'll be focusing on that period, and the mathematical equation for that period t greater than 0 is denoted by this expression, that is f of t equal to m into ut. So this is the mathematical equation, algebraic equation to describe this function for t greater than 0. For t greater than 0, f of t equal to m into u of t, u bracket t, u of t is known as u of t. U of t is known as a unit step function. Now what is unit step function? So before that, here if you see m is known as the magnitude of the step function. What is the magnitude? So magnitude is this. This is known as the magnitude of the function. Magnitude of the function. M stands for magnitude of the function. Is the amount of change that has happened, the value of the change of value in the function. So unit step function, when m equal to 1, this function becomes unit step function. Imagine instead of m, you have 1. The same function, you have 1. Changing from function changes from 0 to 1. That is known as unit step function. So that is the function changes from 0 to 1. 0 to 1. This is 1. This is 1. Value is 1 here at 0. So if the function changes from 0 to 1, we call this as, this is 1. So this is a unit step function. Function value changes from 0 to 1, from 0 to 1 at t equal to 0. At t equal to 0, it changes from 0 to 1. So this is a unit step function, and here magnitude of unit step function is 1, and this is a step function of magnitude m. This is a step function of magnitude m, which is denoted by f of t equal to m into ut, whereas this is a step function of unit magnitude. So what is the equation for this? So the equation for this is f of t, where m equal to 1 here. So unit step function is written by f of t equal to ut. So this is a unit step function. So numerical value of ut is 1. Ut means numerical value is 1, but we represent it mathematically by this equation u of t. Numerical, I repeat, numerical value of u of t means 1. Numerical value of ut equal to 1. But the mathematical way, algebraical way of representing this unit step function, mathematical way or algebraical way of representing this unit step function is this. So this is a unit step function. Now what will be the Laplace transform of u of t? The Laplace transform of u of t. U of t being 1, Laplace transform of 1 is what? 1 by s. So the Laplace transform of unit step function is 1 by s. So this is the meaning of what is the step function and how do you represent it? F of t, these are the numerical values, and this is the algebraic equation for t greater than 0. F of t equal to m into u of t. M is the magnitude of the step function. Ut is known as unit step function. That is a step function whose magnitude is 1. This magnitude is 1 here. This magnitude is 1. This magnitude is 1. So it is known as unit step function. And the Laplace transform of u of t equal to 1 by s. And if you want to write L of m into ut, if you want L of m into ut, m being a constant by the property of Laplace transform, this 1 by s just gets multiplied by m. That's all. L of m into u of t equal to m by s. So that's all. So we have seen what is step function and how do you write this equation and what are the numerical values, what is the sketch, and what is the unit step function, and what is the algebraic equation, and what is its Laplace transform. I hope you understood. So we'll come with more forcing functions in the subsequent or next lectures. Please stand by for those. See you.